There you go. All right, so those not familiar with this pink bunny should get familiar. Her name is Widget, and she's a main character on Wow Wow Wubbzy, the kids show on Nickelodeon. You should check her out. She is often involved in over-engineering technological solutions to main problems in the plot. Her solutions are always over-engineered, always magnificent, and in a stroke of Shakespearean tragedy, at the end of the related episode, she will always say, "Oops, that wasn't the way it's supposed to work." Right? So she serves as my heroine hero. All right, so here we go. DB migrations in Java. Basically, when you're programming against a data instance, there's a number of problems that arise, right? Parallel development is hard to do if you have only one given image of the instances against which you are developing. Traditionally, people will have a whole batch of load scripts, SQL scripts in essence, unless you have a real great support from an IDE or something. And that leads to a number of unintended or undesirable side effects. Number one, if you run your scripts over and over, they are not idempotent, right? So in other words, you run them the first time, you get the desired result. If you run them the second time, in all likelihood, you'll bork your database and be in for days of either rolling back your transaction log or starting from scratch. And in addition, those are people don't typically take the time to make them reversible nor incremental. Therefore, the state of your database is in effect undefined. What this means is that what usually happens in the development environment is that you have one representation of your persistent state, right? And that persistent state is maintained in production, right? Or get test or QA, right? Clearly, this slows down your ability to get things done since everybody's working against different states, right? So you knew this already from your database classes, and the observation is basically this. Any given state of any traditional RDBMS can be viewed as a series of state transactions, right? So if you start today, freeze down your database. The only way you can get that database from one state to another state is by executing usually SQL against it, PLSQL, something else like that, or application code that uses the database's API to do some combination of the above, right? So we know, at a theoretical level at least, that the only way to get from one state to another is by using the API that they give to you. All right. Well, the problem arises when I, on the right, am attempting to develop code that relies on some state, right, that is not reflected in production. While at the same time, my friend Kurt is doing the same thing, but he's attempting to get to another state, right? As long as the problem is usefully partitioned, this may or may not create trouble until your code for your API is committed to your source code management. At which point, depending upon the state of the database at the time of commit, you get into trouble. All right, so this is lifted entirely from Rails. Then there's a partial solution if we make the following observation and do the following things. If you store a database version number in the same way that you might version your code, you can kind of know where you're at, right? Provided that you keep track of what state you're in at any given time. Basically, you decide that as a team that you're going to travel down exactly one path together, right? Even if one person decides to start out at state 5 and another person decides they're going to start at state 2, right? And if you additionally, holy crap. If you additionally provide reverse migrations, you can effectively push your changes in an effective way. I'd be happy to show you a tool later, but it's not like we're going to have time now. The end.